Steve Pollock and I are going to do our best to help you learn Fusion 360. If you open up Fusion 360, you'll get an interface that looks like this. On the right-hand side, you'll find a little cube which gives you your view space and orients your drawing according to that cube. And if you ever lose your drawing, you can click on this little house button which brings you back home. It'll bring the drawing into the field of view. So when we open it up, we have an unsaved document. We're going to save that soon. You will notice we have document settings over on the left side of the screen. And if you click on that, you'll see that our units are in millimeters, and that's what we're going to use right now. We'll just keep it in millimeters. There are name views. There's something called origin. There's a little eyeball next to the origin that allows you to see those planes, the XY, the XZ, and the YZ planes. I'll go ahead and turn that off for now. So the first thing we're going to do is we're going to want to sketch our plate in this workspace. And so we're going to go to the solid tool and we're going to click on sketch. And when we click on that sketch, it's going to ask us to choose a plane. And I'll just go ahead and choose the XY plane. And we have a sketch palette that opens up on the right. Now what we're going to do is under sketch, we're going to create a drawing. We're going to need a rectangle. So we're going to go open that menu. We're going to get a center rectangle. And then I'm going to locate it at the origin. And then I'm just going to left click and hold until I get something close to the dimensions that I want. Okay, so what do we want? We notice that when I stop holding, a little blue window appears on the left side. I want this plate to be 10 centimeters in width by 30 centimeters tall. So I want 100 millimeters on that one side. I type that in, hit the tab button, and it moves to the length. And we want 300 millimeters in length. And finish the sketch. And we are going to look at the front plane. We're going to click on that space and we're going to just go ahead and extrude it. And we want this thing to be 5 millimeters thick. So we hit 5 and there you go. We have a plate that's 5 millimeters thick. Now you can't quite see it in this view because we're on a front view. So I'll hit the home button. It rotates it. Everything looks good. We've got a 30 centimeter by 10 centimeter by 5 millimeter thick plate. I'll go back to this front view. And then I am going to create a hole in this sample. And so I click over here. I go to the center point here. So I'm going to select the face where I'm going to put the hole, and then I'm going to move the hole over the center, and I'm going to adjust the diameter so that it is 10 millimeters. I'm going to go ahead and put the 1 centimeter diameter hole through the plate, and there we have it. Okay, so that's good. We can go home now and all right, everything looks pretty good. So we got our plate dimensioned and we have the hole in it. The next thing we're going to do is we're going to move to the simulation space. So on the left side of the screen, under design, click the down arrow. You see we have simulation. When we go to the simulation space, we're going to hit static study. We're going to create that study, and it's going to ask us a number of things. The first thing, there's this menu bar at the top, sort of tells you the way you should be moving when you're solving these problems. You first assign the study, then you can simplify the geometry if there are parts you don't care about. You can select materials. You know, we should do that. Let's go ahead and look at the study materials that we have. It's claiming that it is steel, and we may end up wanting to modify that in a bit, but we'll get back to that soon. So we'll leave it as steel for now. And we're going to go ahead and look under constraints. I'm going to set some structural constraints. Now we're going to be applying a load to this sample, and we've got to sort out how we're going to support it so that when we apply the load, it doesn't fly off and become a dynamic problem. This is a static stress study. So I'm going to rotate this. I hold down the shift key and I rotate my component. I am going to select a target. I'm going to select one end. I want to select, well, I better zoom in a little bit. I want to select that entire area, and I just constrained it from motion in the X, Y, and Z directions. That's a fully fixed face. that thing isn't going to be allowed to move when I go ahead and apply load. You'll see the little lockdown that occurs right there. I hit OK, and that's done. Next thing I have to do is apply loads. So I'm going to go ahead and apply my structural loads. I have to select the face where I'm going to do that. I'm going to move this around a little bit. And the face I'm going to apply my loads is going to be this end face right here. And you'll notice that they're pointing in. And so, I want to make sure that the direction is, I want it to be normal to the face. And I want to apply 14.6 kilonewtons. But I'm going to go ahead and change the direction. I'm going to make it negative 14.666 newtons. I'm going to hit OK. And you will notice if I hit the home space that I have a sample that's loaded in tension and it's constrained on the other end. And now what we need to do, we have our loads. We don't have any contact problems. We're not pushing something into something else here or sliding something past something else. So everything there looks pretty good. And you'll notice under the solve panel here that we have a pre-check green check mark, which means we're good to go. This problem is good to go. Now what I have to do is set the mesh. So I'm going to go over here and edit the mesh, and I'm going to reduce it to 3%. Now you can't really read that, but if you hover over that arrow, it should pop up pretty soon that I'm at 3%. I don't know why it's not popping up right now, and we'll get to that later. I'm going to go OK. And now I'm going to go ahead and I am going to right-click on mesh and generate the mesh. So it's preparing a model, it's generating that mesh. That's the finite element mesh. And so you think of this as a bunch of trusses, and we are marching through this sample and making sure that all the joints in these trusses are in equilibrium. Now, this is a pretty rough and crude mesh for this particular problem where we know we're going to have high stresses around the through hole. Okay, first thing I'm going to do here is just go ahead and let you know that sure enough, I'm going to edit this mesh, and I'm going to hover over this bar here and let you know that I do indeed have 3% mesh control. Okay, that's right. I'm going to go into local mesh control, and I am going to zoom in, and I'm going to select this edge, and then I'm going to go ahead and flip it around and make sure I select the other edge as well. So I got two edges selected, and I'm going to generate a really fine mesh. So I'm going to see the way I'm rolling this back. I'm going to get a really fine mesh. Okay, and I got to zoom out so you can see. I'm going to go home so you can see that, and then I'm going to click over here and generate the new mesh. And now if you look at that, wow, look, I got the incredible mesh around the edges of that hole, and that looks pretty doggone good. Everything's ready to go. I'm going to go under the Solve tab, and I am going to go ahead and solve for the stress distribution. I'm going to let it solve on the Amazon Web Servers. Clicking Save, I'm going to give it a name, plate with a hole. I'm going to save it, and I'm going to let it do its thing. Right, now it's come back, and I have a solution. I close that window. You're going to notice something strange here. I have this, it always comes back with the factor of safety. So my minimum factor of safety is 2.3. My maximum is 15. I don't want factors of safety. I actually want to use stresses, and I'm going to go ahead and plot the von Mises stress distribution. And I'm going to go up here and change the deformation to the actual deformation. It has a tendency to exaggerate the deformation. And you'll notice that I get a maximum von Mises stress of 90 MPa tension right here on this side. I get a minimum of 3.878 over here. I don't know, that seems a little odd, but let's not do von Mises. Remember, the load is being applied in the x direction, so let's look at the stresses in the x direction. We find our maximum stress in the x direction is around 98, and our minimum is compressive, okay, right along here, along this side. And that's because we are stretching this circular shape into an ellipse, which compresses along the major axes and adds tensile stress along the minor axes. So let's go back to the von Mises stress, and that all looks pretty good. And those are numbers that we can use to determine a stress concentration factor.